Hi, in this tutorial, we're going to go over the basic rules of algebra. So today you'll learn how to understand and use the vocabulary of algebraic expressions, how to use the commutative properties, use the associative property, how to use the distributive property, how to combine like terms, and you'll learn how to simplify algebraic expressions. So first off, terms are the parts of an algebraic expression that are separated by addition. So here we can see that we have 8x as our first term. It's separated by addition. Our second term is 3y, separated by addition, and our third term is 6x. Now, factors are the parts of each term that are multiplied. So here, we can see that in the first term, our factors are 8 and x, because 8 and x are being multiplied. So in our second term, 3y, our factors are 3 and y, because 3 and y are being multiplied. And in our third term, 6x, our factors are 6 and x, because 6 and x are being multiplied. So coefficients are the numerical parts of a term. So here in our first term, our coefficient of 8x is 8. It's just the numerical part of a term. So here in our second term, 3y, our coefficient is 3. And in our third term, 6x, our coefficient is 6. Now, like terms are terms that have the same variable raised to the same power. So here we have 8x, 3y, and 6x. Now 8x and 6x are like terms because they share the variable x raised to the first power. Now 3y is not a like term because it has the variable y and not x. So it is not a like term. Now, constant terms are terms that just consist of a number. They just have a number and that's it. So here, we can see that in our second term, we just have 3. So that means 3 is a constant term because it just has 3. It does not have a variable or anything attached to it. It just has 3. So let's do an example. So use the algebraic expression 4x plus 7 plus 5x to answer the following questions. How many terms are there? Well, we can see that we have 4x, 7, and 5x. So here's our first term, here's our second term, and here's our third term, and they're being separated by the addition sign. So we have 3 terms. So what is the coefficient of the first term? Remember, coefficient is just the number in front of a variable. It's only the number. So here we can see 4 is our coefficient of the first term. So what is the constant term? Now remember, a constant term is just a number. It does not have a variable or anything attached to it. It's just a number. So here we can see that 7 does not have anything attached to it. So that means 7 is our constant term. And what are the like terms? Well, like terms have a variable raised to the same power. So here we can see that 4x and 5x both have x raised to the first power. So our like terms are 4x and 5x. Now, the commutative property of addition states that the addition of two real numbers can be done in any order. So here's an example. So the commutative property of addition states that we can either do a plus b, or we can do b plus a in any order. So let's do an example. Use the commutative property of addition to write an algebraic expression equivalent to 5x plus 4. So we know that we can write 5x plus 4. We can add 5x plus 4, or we can add 4 plus 5x. So that's the equivalent using the commutative property of addition. Now, the commutative property of multiplication states that multiplication of two real numbers can be done in any order. So for example, we could either do a times b, or we could do b times a. So let's do an example. Use the commutative property of multiplication to write an algebraic expression equivalent to 5x plus 4. So we have 5x plus 4. Now we know we can multiply in any order, so we could either multiply 5 times x, or we could do x times 5 plus 4. So here's the algebraic expression equivalent using the commutative property of multiplication. Now, the associative property of addition states that the way in which three numbers are grouped does not change their sum. So we could either do a plus b and then add c, or we could add b plus c and then add a. So let's do an example. Use the associative property of addition to write an algebraic expression equivalent to 6 plus 4 plus x. So here we have 6 plus 4 plus x. Now we know we could either do 4 plus x, or we could do 6 plus 4 and then add x. So here's the algebraic expression equivalent to 6 plus 4 plus x using the associative property of addition. Now, the associative property of multiplication states that the way in which three numbers are grouped does not change their product. So, for example, we could either do a times b and then add c, or we could do b times c and then add a. So let's do an example. Let's use the associative property of multiplication to write an algebraic expression equivalent to 7 times 10 times x. So here we have 7 times 10 times x. Well, we know that we could either do 10 times x, or we could do 7 times 10 times x. So here's the algebraic expression equivalent to 7 times 10x using the associative property of multiplication. Now, the distributive property rewrites the product of a number and a sum as the product of two sums. So here, for example, we have b plus c times a. Now using the distributive property, we distribute a to b, and then we distribute a to c. And so when we do that, we will have a times b, and then a times c. So here, we can distribute a to b, and then we have multiplication of b times a, and then we can distribute a to c, and then we have, that should be ac. So this should be a plus ca. So now here we have b minus c times a. So we can distribute a to b, and then we distribute a to c. So we have a times b, that gives us a times b minus a times c. So here we have b minus c times a. Now we can distribute a to b, and then distribute a to c. So that gives us ba minus ca. We just cross this out. So now here we have b plus c plus d times a. So when we distribute a to b, we have a times b. When we distribute a to c, we have plus ac. And then when we distribute sorry about that. So when we distribute a to d, we have AD. So we have A to B, A to C. So that's how we distribute A to B plus C plus D using the distributive property. So let's do an example. Let's use the distributive property to write an algebraic expression equivalent to 8 times x plus 5 plus 4y. So here we have 8 times x plus 5 plus 4y. So when we distribute 8 to x, we have 8x plus distribute 8 to 5, we have 8 times 5 plus, and then we distribute 8 to 4y, we have 8 times 4y. Now we can simplify this as 8x plus 8 times 5 is 40 plus 8 times 4y is 32y. So that's how we distribute 8 to x plus 5 plus 4y using the distributive property. Now combining like terms lets us add or subtract like terms using the distributive property. So here we have ax plus bx, and our like terms are x raised to the first power. So we can combine them into x and then just write a plus b. Let's do an example. Use the distributive property to combine like terms to write an algebraic expression equivalent to 8x plus 12x. So here we have 8x plus 12x. So our like terms are x. So that means we can combine them into just x. Now we can get our 8 plus 12 and write that here. So we just have 8 plus 12. So we can write that down here for simplicity. 8 plus 12 times x. So that's how we combine like terms using the distributive property. Now, an algebraic expression is simplified when the parentheses have been removed and the like terms have been reduced in an algebraic expression. So here's how we simplify an algebraic expression. First, we use the distributive property to remove the parentheses. Then we're going to group like terms, and then we're going to combine like terms. So let's do an example. So let's simplify 4 times 5x plus 7 plus 13x. So here we have 4 times 5x plus 7 plus 13x. So the first thing we're going to do is use the distributive property to combine like terms. So we're going to distribute 4 to 5x and distribute 4 to 7. So that gives us 4 times 5x is 20x plus 4 times 7 is 28 plus 13x. So write the x down here, 20x. So now we're going to combine like terms using the associative property. So we know we can add 20x plus 28 plus 13, or we can add 20x plus 13x plus 28. So here, 20 plus 13 is 33x plus 28. So that's our answer. 33x plus 28 is simplified version of 4 times 5x plus 7 plus 13x. So today you learned how to understand and use the vocabulary of algebraic expression, how to use the commutative properties, associative properties, and distributive properties. You learned how to combine like terms and how to simplify algebraic expressions. So now try and solve the problems in the Basic Rules of Algebra workbook. For more help, sign up for online tutoring. And in the next video, we'll cover the additions of the real numbers. Thank you.